Hello and welcome. This is going to be our lecture video for April 3rd. I've created this document for you to take notes on, follow along with some of these problems. This one is not an assignment, it's just guided notes. So you don't have to print it off, but if you do, it can be kind of helpful. But as long as you follow along and watch this video, you're going to be done for today. What we're doing is we're just refreshing some of our skills around inequalities to make sure we know how to use inequalities really effectively. And hopefully that's going to help us with graphing linear inequalities, which has been one of the skills for this unit. So I wanted to just take it back to the basics with some good true-false inequality questions. So when I look at a problem like number 1, we can say this inequality in the middle is an alligator and he wants to eat the bigger number. But sometimes it gets confusing with negatives because it looks like he's eating the bigger number right now because 5 is bigger than 4. But with that negative, this one's actually false. And so another way that I think about this is, would you rather have $4 in your bank account or negative $5 in your bank account? And that would represent being in debt $5, which having $4 isn't great, but it's better than having a debt of $5. All right, let's look at the next one. Is this one true or false? Is negative 3 less than or equal to 6? Yep, this one's true. The alligator's eating the bigger number. I'd rather have $6 than negative $3. What about this one? Is 20 greater than or equal to 19.9? Those numbers are pretty similar, but I think we can all agree that 20 is still better than $19.9 in your bank account. All right, 2 negative numbers. So this time the money is really useful because would you rather be in debt $5 or be in debt $7? Well, I'd rather be in debt $5. So this one's also true right here. Even though it looks like he's eating the smaller number, because they're both negative, you actually want to go with the smaller negative. All right, so I went false, true, true, true in that top section. All right, now given two quantities, can we place the correct symbol in between them? So negative 2 and negative 2.5. So which one is further right on the number line? Which would you rather have in your bank account? I'd rather have negative $2 than negative 2.5. I'm in debt, less money there. So we face the alligator to eat the negative 2. All right, negative 0.1 versus 0. So 0 is not a very big number, but it's bigger than negative 0.1. We'd rather have $0 than be in debt a small amount. So we're going to face it to the right. All right, 14 or negative 15. Let's see. Well, 15 is a bigger number than 14, but with that negative, I always want to pick the positive when I've got the choice between a positive and a negative. So it faces this direction. And 1/2 and 3/6. Do I want the 1/2? Do I want the 3/6? These are actually equal. Those are equivalent fractions, so we'll put the equal sign in between there. All right. Now what happens if we want to represent all of the values that make a single variable inequality true on a number line? Well, we have to go to the boundary first. So if the variable b is greater than 4, then I've got to go to 4 on my number line and say this is right where we switch from being false to true. I start with an open circle, then I check and see if I want to fill it in. This doesn't have the little line underneath, so I want to leave it open. And then I want to draw an arrow towards all the numbers that make this inequality true. 5, 6, 7, those would all make this true. 5 is greater than 4, 6 is greater than 4, 7 is greater than 4. And a little trick here is that as long as our variable is on the left, we can look at the inequality symbol to see which way this arrow is supposed to point. Let's try another one. Put a point at 2. This one does have the or equal to, so I fill it in. All right, I want to draw an arrow towards the values that are less than 2. So the arrow comes this way. All of these numbers are less than 2. Negative 7 is less than or equal to 2. Negative 6 is less than or equal to 2. And so on. And we can see the end of our arrow matches the direction of that inequality. All right, 2 more. Let's see if we can do them a little bit quicker. Open circle at 1. Arrow going to the right. This one, open circle at 2. Arrow going to the right. All right, solve each inequality and graph its solution. So here, the variable is not isolated like it was up here. And there's this special trick. If we ever divide or multiply by a negative, that inequality flips direction. So let's copy this one down with some space. 3 minus 8m is greater than or equal to negative 125. I want to isolate m, so that means I want to move the constant to the other side. That means subtract 3 from both sides. And so I get negative 8m is greater than or equal to negative 128. I subtracted, but that's not my signal to flip the inequality. It's whenever I divide or multiply by a negative. Here, to get rid of this negative 8, I divide by a negative 8. Here I'm dividing by a negative. So I've got to remember, when I divide by a negative, the inequality flips. All right, and negative 128 divided by negative 8. Gotta do that in my calculator. It's 16, but it's a positive 16 because the negative divided by a negative is always positive. Now this, I can go and graph. I put a point at 16. I see that it has the or equal to, so I fill it in. And then my arrow goes, this looks like it's pointing to the left, so my arrow goes to the left. All right, one more like this. 7 is less than k minus 5 over 2. I want to get that k by itself, so I multiply both sides by 2. 14 is less than k minus 5. Add 5 to both sides. 19 is less than k. This is an okay answer, but it's hard to graph because the variable's on the right, so I want to flip the whole thing around. And notice when I flip it around, the inequality flips too. It wants to still be eating the k, even if the k comes over here. But this is better because now I can put a point at 19. I leave it open because I don't have the line underneath, and the arrow goes to the right, which is the way that this arrow is pointing. Okay, so always flip it around so the variable's on the left. All right, so in the back here, I've come up with this activity where we are going to check a bunch of different ordered pairs against an inequality to see if they're true or false, and then we're going to plot them, and it's going to reveal to us what the graph should look like. So here I've got a bunch of ordered pairs. All of these ordered pairs fit on this graph down here. And I want to say if they are true or false when I plug them into this inequality here. Y is greater than 2x plus 1. All right, so let's start with the point negative 2 comma 2. All right, every ordered pair is an x and a y, so I want to plug that in to this inequality here into the right spots. So the x has to get replaced with the negative 2, the y has to get replaced with a positive 2. So y is greater than 2x plus 1 becomes 2 is greater than 2 times negative 2 plus 1, which then becomes 2 is greater than negative 4 plus 1, which becomes 2 is greater than negative 3. Is that true or false? Well, that's true. The alligator's eating the bigger number. We would rather have $2 than be $3 in debt. All right. So if it's true, then add a green check. So negative 2 comma 2, this is true, so it's going to get a green check. I'm going to go down to that point on my graph, negative 2 comma 2, and add a green check right there. All right, we're going to redo the graph over here, so everything's going on this graph right here for now. All right, let's try 0 comma 2. So I'm going to plug in, so I'll still label it x and y. I'm going to plug in a 2 for y. So 2 is greater than 2 times 0 plus 1. The 2 times 0 cancels out, so we just get 2 is greater than 1. This also gets a green check. So 0 comma 2 gets a green check. 0 comma 2 green check. All right, 2 comma 2. So again, this is an x and a y. Let's see if we can do a little bit more in our heads. So 2 is greater than, we're going to plug in a 2 for x, so it's going to be 2 times 2 plus 1. 2 times 2 is 4 plus 1 equals 5. 2 is greater than 5. That is not a true statement. So that's going to get a red x at the point 2 comma 2. 2 comma 2 gets a red x. Okay, let's look for a point that's going to be right on the line. Because it says if it's right on the line but still false, example, 2 is less than 2, then add a blue square. So let's look for one that's going to be right on the line. Something like, gotta think, what would be right on this line? If I plug in a 0 and then have a 1, so 0 comma 1, that should be right on the line. Yeah, let's do this one right here. Okay, so 0 is going in for x, 1's going in for y. So I plug those in, I get 1 is greater than 2 times 0 plus 1. 1 is greater than 1. That is technically false, but it's right on the line, so we're giving it a blue square at 0 comma 1. So 0 comma 1 gets a blue square. Okay, I'm going to pause the video here and do all the rest of these, and then resume the video once this whole graph is plugged in. Alright. Okay, and I finished doing this. Here, I'll scroll through these so you can take a look if you were trying them on your own. So you can pause the video here and look at these ones. Pause the video here, look at these ones. Did a lot of the inequalities in my head. I think this was a good opportunity to practice that. And when we plot them all, we see that there's a pretty clear divide between the points that made the inequality true and the points that made the inequality false. And then right in that boundary, we find those points that were still technically false, but very close to being true at this point. So we found the other one was -1 comma -1. When we plugged it in, it gave us the inequality -1 is greater than -1. So that's technically false, but it's very close to being true. So that's why that got the other box right there. Okay, so now we're going to redo this graph over here, but we're going to do it by connecting these 2 points that are right on the line with a dotted line. The dotted line shows that they're not included as solutions, but they're right on the boundary. So the dotted line, all right, and then we're going to shade the side of the line that had all of the correct solutions. All right, and that is what a graph of y is greater than 2x plus 1 should look like. And if we look here, the y-intercept is at 1. This slope here is an up 2 over 1, so that gives us our slope of 2. And so this is why our linear inequality graphs look this way. All right, let me show the whole page here. So, a lot of practice with plugging in points there to get these 9 correct points. And then that leads to this graph here. But in the future, we're going to graph these with just the, looking at the y-intercept, the slope, and the symbol to figure out how to put this line in. All right, that's going to call it good for today's lecture, and have a good rest of your day.